Problem 11. The magnitude of the electrostatic force between point charges Q1 equal to 26 microcoulomb and Q2 equal to 47 microcoulomb is initially 5.70 Newton. The separation is then changed such that the force magnitude is then 0.570 Newton. Here we have two questions. The first question is, what is the ratio of the new separation to the initial separation? And the second question is, what is the new separation? Let's draw the diagram for this question. Here we have two cases. So we will go one by one. So you have to see the first diagram here. Here we have two charges, Q1 and Q2, and these two charges has initial force. So let's take Fi. So this is the initial force, which is 5.70 Newton. And then the separation between the two charges changed. We don't know the separation is increased or decreased, but by seeing the value of the force after you change the separation between the two charges, we have to see what is the force. Here the force is 0.57 Newton. That means the force decreases. That means it clearly shows that we increase the distance between the two charges. So by that, these two charges as the new force. So let's take F final. So F final here is nothing but the final force. So which is 0.570 Newton. By using this information and also by using the value of the two charges, we are going to find two answers. The first question, we are going to find the answer between the new separation. What's the new separation? So this is the distance. So this is the new separation, right? So let's take R final. Here R final we are going to find, and also what is R initial we are going to find. Clear? So once you know this value, we will easily find the answer for the first question, because the distance between the two charges for the initial as well as the final they did not mention. But they need the answer for the ratio. What's the ratio here? RF over RI value we are going to find. So that is the answer for the first question. And in the second question, what we are going to find? We are going to find the value of RF only. Clear? So these two answers we have to find. So let's start with the first question. So I am going to write the Coulomb's law for this diagram. So let's write the formula for this first diagram. As we know, the formula for the Coulomb's law is F, which is equal to K magnitude of Q1 multiplied by magnitude of Q2 over the distance between the two charges square, right? So but we have to mention the initial and the final. So I can write this formula as Fi, which is equal to K Q1 magnitude multiplied by Q2 magnitude divided by Ri square. So this is the Coulomb's law for the first diagram. So likewise, we can write the formula for the second diagram. If you write this formula for the second diagram, we will get Ff final force, which is equal to K magnitude of Q1 multiplied by magnitude of Q2 divided by Rf square. So here I am going to take, this is our first equation, this is our second equation. Now what I am going to do, I am going to divide the first equation with the second equation. So let's divide equation 1 with 2. So that means I have to divide left hand side and right hand side separately. Clear? So let's see what we will get. Ff, so that means Fi over F final, left hand side we divided, which is equal to right hand side we have to divide. So that means K magnitude of Q1 multiplied by magnitude of Q2 divided by Ri square divided by the second equation right hand side. So our second equation right hand side is K magnitude of Q1 multiplied by magnitude of Q2 divided by Rf square. Now I have to modify this equation in terms of multiplication. So if you modify it, what you will get? We will get K magnitude of Q1 multiplied by magnitude of Q2 divided by Ri square multiply, this will go to the top. So Rf square divided by K magnitude of Q1 multiplied by magnitude of Q2. So now you can see we can cancel K with K, Q1 magnitude with Q1 magnitude, Q2 magnitude, Q2 magnitude. So only right now we have two, that means the force Fi, F final left hand side, and Rf square over Ri square in the right hand side. So what we will get, what we have remaining here, we have Fi over F final, which is equal to Rf square over Ri square. Now I'm going to substitute the value of the initial force and the final force. So what is the initial force we have here, which is 5.7 Newton, and the final force is 0.57 Newton. So I have to substitute the value. So therefore Rf square over Ri square, which is equal to, our initial force is 5.70 and the second force is 0.57. So when you divide, you will get Rf square over Ri square, which is equal to 10, right? Now we have to take the square root both left hand side and right hand side. So if you take, get Rf over Ri, which is equal to root 2. So if you find the value of root 2, let's see what's the value of the root 2, root 10, so not root of 10, right? So here the root of 10 is 3.16. So the value of root 10 is 3.16. So this is the answer for the first question. Rf over Ri, which is equal to 3.16. What is this Rf over Ri? The ratio of final distance over the new distance. So new separation over initial separation. So we got the answer for the first part. Now we have to find the answer for the second part. So for getting the second part, what I am going to do, let's we take the equation 2 alone. For getting the answer for the second part, what we have to do, we have to consider only equation 2. From equation 2, I'm going to write the formula FF, which is equal to K multiplied by Q1 magnitude multiplied by Q2 magnitude over Rf square. So we are going to find the value of Rf. So I have to rearrange this equation in terms of Rf. So therefore Rf square, which is equal to K magnitude of Q1 over magnitude of Q2 divided by the F final. Clear? Now I am going to substitute the value. So once I find the answer, once I substitute the value here, we will get the value of Rf square, and after that we are going to take the square root. Or if you want to take it initially, no issue. So better we can take the square root right now itself. So if you take the square root both left hand side and right hand side, so Rf, which is equal to square root of K magnitude of Q1 over magnitude of Q2 over F final. I'm going to substitute the value. K value, as we know, which is 8.99 multiply 10 power 9 multiply the magnitude of the first charge, I think 26 microcoulomb and 47 microcoulomb. So the value is mentioned here. So 26 microcoulomb and 47 microcoulomb. So I have to substitute the value. 26 multiply 10 power minus 6 multiply by 47 microcoulomb divided by the final force. What's the value of the final force? You can see here the final force is 0.57. So I have to write the value for final force, which is 0.57. So let's see what's the answer for the new separation value. Square root of 8.99 10 power 9 multiply 26 10 power minus 6 multiply 47 10 power minus 6 divided by 0.57. So what answer I got here? Which is 4.3 4.39. What's the value here? 4.39, and the unit for the distance is meter. Clear? So this is the value for new separation. So that will be the answer for our second question. Thank you.